Welcome to Mobile Math, Math Lessons on the Go. Today's learning goal, by the end of this lesson, I should be able to divide small positive numbers. So we're going to explore that word divide and what it means. And again, we'll be doing all of this without the use of a calculator. So quick refresher, multiplication is a shortcut for repetitive addition. Product is the result of multiplication, so this is one of those important words. Division is a shortcut for repetitive subtraction. So in math, there's a lot of do's and undo's. Multiplication and division are do's and undo's. They're opposites of each other. So in division, though, quotient, which is a very strange word to start with, but that is the result of dividing numbers. So you end up with a quotient. So let's begin. So division notation, there's a whole bunch of ways of showing division. It's just probably what makes it a little bit complicated. We have this little symbol here. This means division. It's a line with two dots, one above and one below. We have a fraction form, which we've kind of seen. And then we have this guy here, which is the long division or traditional way of writing division. And we'll get to that in a future video. So what does it mean? So case one, if 8 was divided into two equal groups, how many chips, counters, etc. would be in each group. So we're going to take our 8 and split it into two equal groups, and we'll do that on the next page. Or case 2, how many groups of 2 are there in a group of 8? And we could also say that as how many groups of 2 can I subtract from 8? So those are the two main cases we'll experience with division, and the rest of our examples will fall into either case 1 or case 2 being the best way to think about it. So let's start with 8 divided by 2, and let's actually come up with the answer. So case 1, I've got a little picture here. I've got a little area model, which we will continue to use. So in case 1, if 8 was divided into two equal groups, how many chips, counters, squares, etc. would be in each group? So if I physically take my 8 squares here on the left, and I break them up into two equal groups, we can see that both groups have a total of 4 in each of them. So 8 squares divided into two equal groups of 4. So my answer to 8 divided by 2 is 4, because that's how many chips, or squares in this case, are in each group. So if we look at case 2, how many groups of 2 are there in a group of 8? So if I take my group of 8 and I look at how many groups of 2 there are, you can see right here that there are actually 4 groups of 2. So regardless of whether I interpreted the problem as case 1 or case 2, I still end up with the same answer of 4. So let's see if it works for all numbers. So let's start with 18 divided by 3. So we've got some bigger numbers. So case 1, if 18 was divided into 3 equal groups, how many chips, counters, squares, etc. would be in each group? So I've taken my physical model of 18 squares here. I've broken them down into 3 equal groups over on the right-hand side. And if I count them up, I can see pretty quickly that each group has to have 6 in them. So 18 divided by 3 equals 6 from case 1. If I look at it from a case 2 perspective, how many groups of 3 are there in a group of 18? So if I take my 18 again and I break them down into little groups of 3, I can see that I have 6 groups of 3. So both case 1 and case 2 end up with the same answer, that 18 divided by 3 is 6. So if we look at our area model again, just a quick refresher, the dimensions, those are the outside numbers. So the outside dimensions multiply to get the area, or how many squares are on the inside. So in this case, 8 times 3 or 3 times 8 gets me 24 squares. So can I use this for division? Of course I can. So the difference will be, instead of knowing both numbers on the outside, I will only know one number, but I will also know how many squares there actually are. So if I look at this one here, I know I have 24 squares. I know this dimension on the left side is 3. So it's a matter of counting up how many squares would have to go along the top to fill in that area model. And we're going to try that in the next example. So I have 3 ways to look at this, and we'll see if we can come up with 16 divided by 2. So case 1, if 16 was divided into 2 equal groups, how many would be in each group? So I've chunk these together here. So if I put 4 in group 1, I need to put 4 in group 2. If I put another 4 in group 1 and another 4 in group 2, we'll see that each group has a total of 8 chips, or in this 8 chips in each little box that I've created there. If I look at case 2, how many groups of 2 are there in a group of 16? So I'm going to interpret this one as how many 2's can I subtract from 16? So I have done repetitive subtraction here, and you'll notice that I have done that 8 times. So I have subtracted 8 groups of 2 from my original 16 to eventually end up with 0. Case 3 is an area model, 16 divided by 2. Well, if I know this dimension is 2, I'm going to cut my area model like that, because I know I have to have at least 2 along that dimension. And then I'm going to start chopping this up until I end up with 16 squares. So right now I have 4. If I make a couple more cuts, I'm up to 8. If I make a few more cuts, I can see now that I have 16 squares, and that this dimension along here must be an 8. So again, 16 divided by 2 must be 8. So if you could press pause on the video and try the following. So we want to find the quotient for the following. So please press pause now. Okay, welcome back. So we'll try and do this a couple different ways. So 9 divided by 3, you'll notice I have 9 blue dots here. And I'm just going to break this up into 3 equal groups. So if I break this up into 3 equal groups, I can see that within each group there is 3. So 9 divided by 3 is 3. 14 divided by 7, I have 14 yellow squares here. So if I want to see how many groups of 7 fit into 14, well, there's one group of 7 here and a second group of 7 here. So I have 2 full groups of 7 that fit into 14. Lastly, 20 divided by 5, so I'm going to use an area model here. I know I need to have a total of 20 inside the box. I know one dimension is a 5 here, so if I use some friendly numbers, I might say that those 2 boxes each have to have 10 in them, because that totals for an area of 20, and then 5 times something gives me 10. Well, that something must be 2, and a 2 here as well. So if I add those 2 together, I know the missing dimension here must be a 4. So 20 divided by 5 is 4. So thank you for watching. Please watch again and pause where you may have had difficulties, and good luck in your future math problems.